Hi guys, thank you, Anna. I'm glad to be here for a second time. And today I'm going to tell you about how we are using WebAssembly at Fluence. In particular, the agenda of my talk is as follows. So first of all, I will tell you a bit about Fluence, what we are doing and how. And then we are talk a lot about what is Marine runtime, how it looks internally, and explore some tools around Marine. Marine is our general purpose runtime that is based on interface types and the model linking. And also it exposes sharedness and linking scheme possibility to link modules. And as the last section, we will cover a bit the last topic that is about our intermediate representation called AIR and about Aqua VM, our virtual machine that interprets this AIR and that located inside Marine on our network. And let's start with Fluence overview. And Fluence is a so-called open application platform. In its turn, open application platform is a thing that consists of three main other things. First one, as usual, Web3 project, it is P2P. It's completely decentralized, and this P2P nature allows Fluence to compose different APIs, different services, data, processes inside network, and so on. It could be said that from the developer point of view, Fluence is about composing. It's about composing everything. We could compose modules in the servers and the services with help of our new language into some so-called super service. And second two things here is about marketplace, is about monetization. We believe that in the future, Fluence network will allow developers to get paid automatically by the fact that their code are used by anyone in Fluence network. And the second important things here is Aqua. Aqua is our programming language that inspired by P-calculus and especially by process calculus. And this language allows to program network requests across our network. It's designed to coordinate and orchestrate network calls without any central gateway. So all peers inside our network are peers. There are no any leaders. They play the same role. They could host services. They could be relay and so on. So they completely decentralized. And Aqua is interprets and is interpreted by every service at once. The third important thing here is services. Services could be considered as usual as general microservices. They first of all WebAssembly based, and that's why they're sandboxed by design. I will show you later on a dedicated slide that a developer could set settings for each module inside services. It could have different constraints, different abilities, and they could play different role inside service. On the slide, you could see a model of Fluence network that consists of three peers and two clients. Clients usually browsers, and Aqua allows a user to compose these services located inside peers and compose their through WebAssembly interface types. Each service could be either stateful or stateless. They could access hard drive through WASI. They could also call some external services through spatial gateway functions. We will also cover their later. And here you can see on the right side that one service could interact with three other different services that are in orange boxes. Here you can see IPFS, some unknown microservice, for example, databases like MariaDB, MongoDB, Oracle, and so on. And this like microservice written on WebAssembly allow you to interact with some I don't know, well-known services that can't be, for example, compiled to WebAssembly. And it's the power of Fluence and power of composing. Let's dig into Marine runtime in details. Actually, you could see my previous talks, and where Marine was called FC. We have changed name about several months ago. So please, when you see Marine, when you see FC in our code base or in the slides, please notice us and think about it is about Marine. From the service-oriented view, Fluence could be considered as in a following scheme. Here you can see that we have several modules form a service. Here modules is a usual WebAssembly modules that compiled with our SDK, and they link together and form one service. And in turn, several services could form a so-called super service or backend. And it's important that these services could be located somewhere in network. It doesn't matter where. They could be on one peer, they could be on different peers, it doesn't matter. With help of Aqua, there could be composed to some super service. And for users, this super service could expose functions. And they are they're transparent for users. And also it could be seen as a function as a service. But it's a bit more, of course, than just usual function as a service. And as I said, Fluence service is just a group of modules that link together with help of shared nothing linking scheme. And as you know, shared nothing, so actually there are two types of linking. The first one is shared nothing, the second one is shared everything. And the difference here is what module exposed to external world. For example, to a host runtime or to other modules. In shared nothing linking scheme, there are only exports and imports that are visible for different modules, for other modules, except this one. And in shared everything, module could expose everything. Yes, for example, constants, globals, tables, memory, and so on. Marine currently support only shared nothing linking scheme, and the scheme actually could be implemented only with help of interface types. So under the hood, we are using WebAssembly. We are using Wasm as a base runtime, and Wasm crate that was highly modified by us, called interface types. And with help of that, it's possible to make such a scheme where, for example, you have a service that consists of 3 modules. One facades, it's one that just expose API of all services. And second one, for example, could be some database like SQLite. We have SQLite that ported to WebAssembly, also in such a way that is compatible with other modules and with interface types wrapping in our Marine. And the third one, for example, could be some authentication module. Yes, it doesn't matter why. An important thing here is that they linked by linking corresponding imports with corresponding exports, is shown on the scheme. So each module encapsulates all state inside. So no other modules could access to some memory data and so on. And we have 3 types of modules. The first one that I already mentioned is facade. This facade module, they expose API of all modules in service, and only there could be only one facade module in service. In config, the last one, and only these modules could be called from Aqua scripts. No other modules are all other modules are inaccessible for Aqua scripts. Second one is pure modules. They can't access file systems. They can't call external binaries. They just should contain pure logic. And the last one is effector. Effector Survasi could access file system, could call external binaries, and some other stuff. So the difference here is that pure modules could be safely loaded into each service, into each runtime that located somewhere on user machine, and they're completely safe. And effector modules, they could access file system, but they could access only with constraints, with some settings. And let's show how it's look like. Here you can see service configuration. Each service has a configuration file. It's based on a TOML format config. And here you can see that this example of so-called URL download service. It's the simplest one. It consists of 3 modules. The last one is already set is facade. It should be set as the last one in config. And here you can see that there are no other special settings. Second one is a curl adapter. This one is different from facade because it has mounted binary sections. And the sections allows this adapter to call external binary through CLI interface, through standard operation system CLI interface. For example, this module could call curl that located with through this path on the operation system. The last one is local storage. Remember that this is a simple example, just it's intended to show possibilities of linking. There are no any logic to split this into 3 modules. There, we could see on examples that they're rather simple. There contains, about 20 lines of code, but and that's just example. And here you can see that there are a bunch of additional settings. For example, for this module, for local storage, we could enable special logger. I will not cover this logger because it's not so interesting, and you will find it well described in documentation. Next setting is setting about count of memory pages that can be used by this service. These pages are WebAssembly pages of 64 kilobytes, and we could set this setting for each module. So we could set maximum amount of memory that module could use inside Marine and inside the operation system. And also the last setting here is Wasm. With Wasm, we could set which files and which directories are accessible, could be accessible from this module. For example, here there is this directory site that located somewhere near the binary of module, and also we could map it to we could make aliases for this directory to access it through aliases, but not through a whole name. Okay, and from general perspective, Marine could be presented like in this slide. Here you can see that in Marine we could load several services at once, and they could consist of separated modules. There are not any interdependence between them. They're just each module belong to only one service. And here you can see also that through Wasm, effector modules could access to operation system, call external binaries, and so on. Marine has so-called layered architecture. We have 3 layers to feed different purposes. On the third layer, so that layer that contains app service and Aquamarine VM. This layer intended to run services. That's aim of app service, and to run Aqua virtual machine. That's aim of Aquamarine VM. But actually, Marine, the second and the first layer, could be used in another different scenarios. I think that's probably most important one and most useful here is the so-called entity component system pattern that widely used in games and in scenarios when you need some plugin system inside your other system. So I believe that Marine could be easily integrated to other projects and used as a used to allow a CE pattern. And on the first level of engine, We have like a lot of APIs. Here you can see only important ones. For example, you could load module with some module config. In module config, there are some settings that we covered on previous slides, and one that dedicated to host closures. I will cover it later. Also, you, of course, could unload module by name, and while module loaded, you could call it by name, call by function name, and with arguments. Here, please note that there is iValue. There are no, in arguments, there are no any role types. iValue is a enum. I will show you later what fields it consists of. And also you could expose state of WASI state of module and module interface. Here by interface, I mean interface of modules, exports functions that module expose that could be called from a module. And second layer that also could be used not only by us, they intended to like provide several variants of constructors. They also provide several functions to work with configs, and it has a function that mimics for call, but receives arguments not in this form, but in form of JSON. So you could just call it with JSON arguments and get also JSON arguments. And also it defines several host imports that's special for network. And iValue that I mentioned previously looks like this. Here you can see that iValue consists of general Rust types. Yes, it's here you can see like some primitive types, strings, vector of bytes, vector of different types, and records. And host closure that I also mentioned looks like this. So here, this one is intended to code closure that could be called from a module. It could be called from module imports. In many projects that I have seen that based on different runtimes, Wasm time, and so on, host closures were based on role types. So you should manage your own by your hands, yes, how arguments will be passed from Wasm to host and so and in different direction. Here you can see that this mechanism provides you a way to abstract over it and work on with iValue. So there are no any role types. Of course, you could access to memory with this context. It's Wasm context, but in many almost all situations, it isn't needed here. And on the slide, you can see how import for mounted binary that like option mounted binary that each module could be extended works. So here functions that return this host import descriptor, and inside it there is a like closure body. This closure body receives arguments and receives context that isn't used inside this closure actually. And here there is a special function that implements calling mounted binary. It doesn't important, just usual Rust function. And here you can see that so the results here actually it's just a Rust structure. And like we have special function called to interface value that wraps this result into iValue. And like this return result. And the whole function returns this host import descriptor that consists of some additional fields, like this host closure, this body that I covered previously. Argument type should also be specified. Yes, because it's dynamic linking that's supported by Wasm. But like to link it properly, we need to know types that closure should receive to allow, for example, type checking. And also the same for output type. And if there is some problem, for example, in lowering or lifting types between raw WebAssembly types and some non-simple Rust types like string, vectors, and so on. There is special error handler that looks like this. It's also closure that allow you to do some, I don't know, some recovery after error or print some error message or something like that. And the whole import looks like this. Here, please also notice that there are no any things related to raw arguments. We work with iValues, and we receive iValues and we return iValues. There are no any issues with reading memories, writing memories, and so on. Okay, let's cover the next topic that dedicated to Marine SDK and tools around. Hello World for Marine runtime looks like this. It's similar to Wasm engine and to other different projects. Here, please note that there are no any traits that you should implement it. There is only that differs from like vanilla Rust function. Here is only this procedure macro. So this macro means that
recording in progress.
That this function greeting will be exposed and will it became expert from this module. And here just a hello world. Yes, it's I know 6 lines of code, and it allows you to code on vanilla Rust with some limitations, of course, because Marine macro, for example, doesn't support traits, generics, and like stuff like box or C and so on. But this will be added in future. Like previously, I covered where download the service and showed config for it. And here, let's see how it looks like from a code perspective. Because here, remember that it consists of 3 services. They're just really simple ones and contains 20 lines of code. And how it looks from a code perspective. It's this function is function from facade module. This function allow you to download some some bytes from URL with curl, and then save within the file. And these 2 functions, download and file put, they're from different modules. And to allow this module to use it, yes, there is this known Rust FFI mechanism that here is also used, and the only thing that you need to add is also Marine macro here, Marine procedure macro, and also specify from which module this function should be called. And here also link name is also works. For example, this function that in this module called file put, actually it imports with name put from module called local storage, and curl and local storage modules looks like this. Like in real example, it's a bit longer. You can find it's this by this link, but here's the main logic, and here you can see that this download function actually will call this function without any additional work. It just work with Marine. Also, more complex example, of course, supported. For example, here you can see that records could be used, and records could be also contains fields that in it store other records, and also we support passing by reference in imports and exports. But please note that since it's a shared message linking scheme, memory is copying, and the passing in exports by reference is like a syntactic sugar. It doesn't allow you prevent copying, additional copying. Okay, and here I want to cover something special. Actually, it's special because I haven't seen such possibility in other projects. This is how we approach in testing. So to to allow users to test their code in the same way as it could be loaded in Marine, we introduce a new macro called Marine test, and here you can see how it works. Here also our whole world that contains only one function, greeting, and imagine that we want to test it. And to test it, we write tests as usual, we wrap it with KUG test and so on. And here, except just test that we should write in vanilla Rust, here we need to write Marine test. And in attributes, we should specify path to config file and path to modules. Yes, folders that contains all modules of the service. And we also should specify an arguments like this one. This is all code that should be generated by this macro. And inside it, we could operate with export functions from this module. It's different. This code won't be compiled to WebAssembly and code. It works a bit different. Here, new Marine instance will be created. This Marine instance will load all modules from this dir, and according to this config, and all modules from this one will be supported from Wasm. So here we test not a native target, we test a Wasm. So by calling this greeting, actually we call Marine, and in Marine we call functions that compile to WebAssembly. This allows users to make comprehensive tests for service that contains several modules, because you could access different modules. Modules should be specified into arguments of function, and only this module could be accessible inside this function itself. And this approach is very flexible. Also, we are working now, and this new version will be ready in 1-2 weeks. This version of Marine test allows you to test several services at once. We could specify services as the previous one, but with specifying their names, like here. And also we could interact with services and each module that each service contains. Here you can see example for where service one is called, especially this facade module that provides function called process data is called from service one, and the result of this code is then passed to process data of service two. And with this result, we could do something, for example, compare it with some, expected value or something like that. So here scheme is different from other projects, because here, except this, again, this function isn't compiled to WebAssembly and then run. This function is run as native, but all calls of the function, they actually call WebAssembly code, compiled to WebAssembly. And this tests allow you to test services as more close to how it will look like inside real runtime as possible. And let's cover last topic of this section, how the multi-module calls work internally. Also remember our example with 3 modules of real downloader service. And actually for each function that imports or either export, there is a dedicated interpreter. This interpreter is the interpret interface types instructions. For example, here we have seen 3 modules, and for each module there will be different Wasm instance. Yes, for facade, curl, and local storage. And for each export and for each import in this instance, there will be corresponding adapter import and adapter export. And imagine that we could call, we want to call function kuru from a module kuru. And to call this function, there is a bunch of code of interface types code that should be executed. So at first, there will be executed these 4 instructions. They are intended to lift string. Remember that kuru has kuru receive string and produce string. It's 1 argument and 1 output value. And this code is intended to lift string from memory of kuru module and then call kuru adapter, this one. Next step, there will be like these instructions. These instructions are intended to lower string into a memory of kuru module. Yes, here you can see, for example, functions that lower memory. Actually, these instructions do like first they allocate memory of string size that passed from this adapter from the left side. Then it called lower memory that copies string from a host memory to a kuru memory, this module memory. Finally, like real function from an instance will be called. It's like after lowering, yes, we could use row types, and with row types we could call row Wasm function. And the last step here is to pass result string back to the facade module. Here we like in expert adapters, the only thing that we need to do is just to lift memory back, lift string, and then we should lower it back, should lower it to a facade memory. So that's how interface types works. It should be noted here that we're using now the first version, so-called first version of interface types, because the interface types proposal was completely changed about a year ago, and now like we are waiting when it became stable to use the second version of interface types. But currently, the first version is work. We added several instructions. For example, you can see here DAP and swap to. There were no such instruction in the specification, but it's impossible to implement such a scheme without them. Also, we did some work to optimize the scheme to like specialize some, I don't know, some instruction to allow them work better than it was initially written, and so on. So it's just work, actually. So regarding tools, like we have tools. The first one is called Marine, and it's in like aims to compile modules. It works as a Wasm pack or I know, or other tools that, for example, as a Wasm engine, is that uses two stages compilation scheme. Marine is also exposed such a scheme, but I think it's not so interesting. More interesting here is REPL. This tool is intended to test services by hand. Yes, here you can see that services code IPFS loaded inside REPL, and here it contains two functions, IPFS pure, two modules, IPFS pure and IPFS effector. And we call the first one with JSON serialized arguments. That is actually an array with 3 numbers. And this is put this code internally through CLI interface. It's called IPFS put. So it's like store inside IPFS network this piece of data. And by using hash that provided by this function, here we could get back our 3 numbers. Yes, and you can see that their number is the same. Okay, how fast is it? Like with SQLite, we also supported Redis. Redis is also accessible in our network. you could use it as a building block of services. And here you can see some numbers. For example, Redis instantiation takes about half a second. And by instantiation here means, first of all, compiling from WebAssembly to native, and some work to instantiate import exports, interpreters for exports, and so on. So function call, usual function call, here you could see that takes 67 it's microseconds. The first call takes a bit more, about 3 milliseconds, because we have some lazy linking inside, and all next calls will be faster. Okay, let's cover our last topic that dedicated to air in our Aqua virtual machine. As I said, we introduced a new language called Aqua, and here you can see a simple example, of simple code written on Aqua. The full code could be found by this link at the bottom of the slide, and here you can see application called FluentPath. That's collaborative editing, and this function handles user joining. Here you can see that this function receives one argument, user, and returns join results that have this structure. And this function is the same. It goes to peers that are identified by app user list peer ID, and on this peer, it calls service called user list that identified by this service ID, this one. And on this service, function join is called with argument user. And the result of this calling is returned from the whole function. So that's how you could transmit through Aqua and with the operator on, you could transmit execution flow to peers that are identified by this peer ID. It's pretty easy. Of course, I won't cover the whole topic about Aqua. You could find a lot of documentation and a lot of videos on our channel. But Aqua, why I mention it? Because Aqua actually compiled to our intermediate representation called Aquamarine intermediate representation, AIR. As a compiler here written on Scala, and it just compiles. This AIR then interprets by our interpreter. This interpreter written in Rust, and it's then compiled to WebAssembly, and then it could be loaded inside Marine runtime. So here you can see our complex scheme where code written on Aqua compiled to AIR, and then it could be launched on our interpreter that's in its turn loaded into Marine. But it's for user, there are a bunch of tools that allow to automate all of this. And also with, again, here this interpreter is loaded into Marine. And Marine runtime are allowed only to launch into nodes, not in the browser. But also this interpreter, exactly the same, works in the browser with browser runtime, and also it could be loaded into Node.js, exactly in the same way. And this interpreter works in such a way that it interprets about 10 instructions, as they're inspired by process calculus and p-calculus. They just allow you to program how network requests will be moved across your network. And from a formal point of view, this Aqua virtual machine is a pure function that takes two data, previous one and the so-called current data. This current data is data that comes from a network, and previous data should be stored into a node that manages such interpreter. And the result of this is a new data and a list of peers where this new data should be should be sent. And this function actually is like state transition function. It's just some form of like finite state machine. It's a pure function. There are no any imports here, and that's why it's really easy to run it on a browser or Node.js and something like this. It allows also host like Node or browser works in a synchronous way. Because there are no any blocking calls here. It just interprets instructions and provides like some form of commands that know that host should be should follow. Okay, here you can see another picture. It's how like our network could be represented. There are two layers. The first layer is the execution layer that is handled by Marine. And into this, like, and we have peers that could load several services, and also with services, Aqua virtual machine is also loaded. And in turn, these peers could be composed by Aqua. That's also another way how to like present yourself Fluence network. It consists of several nodes, again, peers, and we have several dedicated peers called clients that usually like browsers. Each like peer here runs Aqua virtual machine on nodes that not browser. They run it through Marine, and on the browser they run through browser runtimes like V8 or SpiderMonkey. And from a Marine point of view, interpreter is just a module, just a service that consists of one module, but with special host closure. This host closure is something special because it allows interpreter to call different services, because services itself can't call other services. They could call, communicate only through modules that form the service. Okay, and today, like I presented you several things that we for that we use WebAssembly in Fluence. I covered Marine virtual machine. You could find it by this link. Our SDK and tools. You could find this by Rust SDK link, Aqua. And if you're interested in our project and if you want to follow updates, please join to our Twitter, subscribe to our Twitter. And if you have any questions, if you, for example, watching this in the record, you have any questions, so please ask me by this email or by this Telegram nick or through issues or somewhere. So we're very open for any questions, for any proposals. So please, I know, find us and ask them. Thank you very much. I would be glad to hear there. So hope you enjoyed.